Okay, so the first part of this is to find the current in branch CD, which is I2, and we know from Kirchhoff's current law that I2 is going that way into it, and I1 is going that way, and I3 is going that way. So I2 should equal the sum of I1 plus I2. 2.0 plus 0.60 equals 2.60 or 2.6 amps. Should be 2SF because when you're adding and subtracting, you go to the one with the least number of significant figures, or the least number of decimal places I should say, which is this one. Okay, and then B, we're asked to write up a voltage equation using Kirchhoff's voltage law for loop A, B, D, C, A, B, D, C, A. So if we start at A, we're going in the direction of the current, so there is a voltage drop across the 1.1 ohm. Let's just go up a fraction. So I1 times 1.1. I'll just put them in brackets. We know what I1 is now. Or we did already, so current times, okay, V equals I times R, that's what we're using. 2.0 times 1.1, and we're losing, it's a minus, and we're going from minus to plus on the cell, so this is going to be a plus, and that's, I think it's given as V1. And then we're minusing, because we're still going with the direction of the current, and we're going from the more positive to the more negative, so it's going to be minus, as I said, 2.0 times by 11 ohms, and then B to D there's nothing, and then in D to C we're going with the current again, so we should have another minus. I'm going to carry on with the equation underneath because otherwise it's going to get a bit hard to see what's going on. But minus the current I2, which was 2.6, times by the resistance 0.60, and the last one we're going from minus to plus again on the 12 volt, so we're increasing in potential, so it's going to be plus 12, and there's nothing in the C to A, so all of that should equal 0. Okay, I'm just going to shrink that down a bit too, hopefully it's not going to make anything less visible. So then that's our entire equation. I'll just put a square around it so I know what we're dealing with. And we're now moving on to C. Gosh, jumping ahead of myself. C is calculate the voltage of cell 1. So cell 1, V1, we want to know. And we can do that using this equation because that is our only unknown in the entire equation. So let's see. We should be minus 2.2. 2.2 plus V1 minus, this one's minus 22 and then minus, okay, let's just do a little mental calculation. I'll pause it while I do that. I think it was 1.56, so minus 1.56. Let's just double check that. So it's 2.6, 0.6, 6 sixes are 36, carry the 3, 6 twos are 12, 13.15, and now this is a tricky one because there's 2 decimal places, so it should be 1.5, that's what we got, that's good. Okay, and then finishing the equation, it's plus 12, so bring that across, plus 12 equals 0. So coming back to the equation again, we want V1 by itself equals 2.2, this is putting it all on the right hand side, 2.2 plus 22 plus 1.56 minus 12. Okay, so what does that equal? Okay, I think it's 13.76 volts, and if we were doing that to 2SF, oh, it's all adding and subtracting, there's a bit of multiplying divide, yeah, probably go to 14 volts, but anyway, we'll keep it there because I think we need that to calculate the last one. D is the voltage of cell 3, so I'm going to come down this way, I think, and go crossways. Voltage, so D is going to be in here, voltage of cell 3. We need to do another voltage loop, but it's going to be C, E, F, D, I think. So we'll do C, E, F, D, and back to C. That's going to give us nothing from C to E. E to F, we've got 0. We're losing across the 0.15 ohm resistance, so it's minus 0.60 times by 0.15. Then we're going from minus to plus, so we're increasing over V3, so V3 is a positive thing, so plus V3, and then we're minusing across the 1.8, so minus 0.60 times by, what is it, 1.8, and then from F to D there's nothing, and then from D to C we've got two parts. We've got the plus 12 as we're increasing there, and we've got the minus I2 times 0.6, so this minus I2 was, what did we work it out to be? 2.6 times by, the resistance was 0.60, and then it was plus 12. Okay, and then from that we can work out what we're dealing. So this is our equation a little bit, oh, that'll equal 0 as well. But I'm just going to shift across here to continue with this calculation because it's a bit awkward. So 0.60 times 0.15 is, let's see, 6 5s are 30, so it's 0.09 I think, plus V3, that's a minus by the way, plus V3 minus 0.60 times 1.8, so 6 8's are 48, so it's 10.8, but it should be 1.08. 1.08. Does that seem about right? 0.5 times 1.8 would be 9. Hang on. 6 8's 48. 6 1's 6. Yeah, I think that works out right. You can double check that. I'm a bit fuzzy at this time on a Friday afternoon. And then you're minusing again 2.6 times 0.6. 6 2's are 12, and 6 6's 36, so 15, no, that's not going to work. Let's just write it out up here. 2.6, 0.6, 6 6 36, okay, the 3, 6 2's 12, we did this one before, and it's 1.56, isn't it? That makes sense. Minus 1.56 plus 12 equals 0. So V3 by itself, V3 equals 0.09 plus 1.08 plus 1.56 minus 12, and this should give us a negative. I may have done something wrong, unless when unless this battery actually is connected opposite direction to which they say it is. But let's see, 9, 8 and 6 is 14, 23, so we've got 23, 3 carry the 2, 2 and 5 is 7, and then 0.2, I think that works out, minus 12. If it was minus, oh gosh, I hate these things, minus 12 plus 2.73 means we're going to be minus 9.27 volts. The minus should mean it's just in the opposite direction. I'm not sure the answers, so I'll just have a quick look. Okay, so I found out looking at the answers that I misread I3. This is actually meant to be 6 amps, 6.0 amps. So you'd have to redo all of my calculations with 6 amps in place. I'll just go through and circle them really quickly. I think it was, well, everything really affects it. So so that's that first one, so that's going to affect this, it's going to affect this, it's therefore going to affect what V1 turned out to be, and it's going to affect, where are we? That's going to affect the whole thing. Anyway, substitute that in, go through the same process but with the other one and see what you come up with.